mathematics, probability is a measurement applied to events. Words are used to describe this level of belief, ranging from impossible to certain, based on evidence that we assemble around in relation to the event. Now it's time to explore the concept of random sampling using a what's behind the door scenario. We have two doors. One door has a dog behind it and the other room is empty inside. You have no way of knowing which door has which item. You are asked to pick a door. So the chance is 50-50, so each door has an equal likelihood to having the dog behind it. This sounds sensible, yes? So which door should you pick and why? In this situation, we are looking at random sampling. Closer look at the concept of random sampling. Bobbers states that if an event is to be classified as random, all possible outcomes have an equal chance of occurring. For example, when tossing a coin, the chance of it landing on heads or tails is equally likely. Hence, the outcome is based on chance. So, there is an equal chance of you choosing the correct door. Now that we have established that each door has an equal chance, let's discover the outcome. As you can see, you have now won the dog. Now that we have opened the door correctly and seen the outcome, let's take a look at the misconceptions associated with this concept. One common misconception is to think that every situation with two possible outcomes is a 50-50 situation. Many people think that just because two outcomes are possible, each outcome must have a 1 out of 2 chance of occurring. But that's very often not the case. Not every situation is like a fair coin toss. Many situations have a higher probability of one outcome over the other. For example, think of a computerized walk, don't walk sign on the crosswalk of a busy street. Is that sign going to say walk exactly 50% of the time? No. When the street is busy, the light will stop traffic less often, and pedestrians will have to wait longer between opportunities to cross the street. To avoid some of more common probability misconceptions in the classroom, teachers should keep in mind the following. Probability isn't effective in predicting short-term behaviour. It is effective when predicting long-term behaviour. In the case where only two outcomes are possible, each outcome doesn't necessarily have a 50% chance of occurring. You can't be on a roll if a process is being repeated over and over under the same conditions. Probability has no memory. Finally, sequences of outcomes that look more random oftentimes have the same probability as sequences that don't look as random. Thank you very much for listening, and we hope you enjoyed our presentation.